In this brief lecture, gang, now we saw how to calculate the derivative of the natural exponential function, so it seems reasonable to ask, well, what about the antiderivative of the natural exponential function? Okay, so let's say, recall, right? That second one we showed by way of, we found a pattern, okay, and we use the product rule. So here, K is a constant. And then we saw by the chain rule, a natural extension of the chain rule, that if we have e to a function, okay, right, it's a composition where some differentiable function was substituted or dropped inside the natural exponential function, then the derivative of it would be itself. Times the derivative of the exponent, which is g of x, okay? So let's just jump in and just start out with some examples. What would you say to this? What do you think? Right, gang, remember now, this right here, this is the derivative of some function. Don't forget, we should never lose sight of that, right? The integrand is the derivative of some function. Let's call that function capital F. So this would be as so. Okay, so you have to give me back a function whose derivative is exactly 4e to the 4x. Well, based on our previous work, that would suggest okay, plus a vertical shift. And you know that we've always known, right? You can take the derivative of this result to get back to the original integrand. Okay, so let's make a note. Okay, and you can check that as you like. Okay, how about this? Now, this is a little bit more complicated. What do you think? Yes, good. It looks like a chain rule. And in fact, you would be right. Notice that the outside function, e to the x, is exactly the derivative of the inside function, 1 plus e to the x. Gang, that's our thing. That's our special case of the chain rule. Let me rewrite, okay? Okay, now that we recognize it for what it is, we can go right to the answer. Okay, of course, you can use the substitution method to find the same thing with a little bit more work, but recall we found the antiderivative of all such special cases like this, right? One time for all time. So keep that in mind, all right? But like I said, if you want to use the substitution method to verify, absolutely you should do that. Okay, so this one, I think what I'll do is I'm going to rearrange the factors. And with that, I can see that the 1 over x squared is the derivative of the exponent 1 over x. So we have a chain rule. It's not the special case of the chain rule, but it's a chain rule just the same. And we're off by a factor, gang. How much are we off by? What's the derivative of 1 over x exactly? Yeah, good. It's negative 1 over x squared. We have positive 1 over x squared. So let's fix that. Okay, so we'll multiply by a negative on the inside and a negative on the outside. Otherwise, we've got a perfect chain rule now. I'm going to set that minus aside right there. Otherwise, this is going to be e to the 1 over x plus c. All right, and I encourage you to check that. Don't take my word for it.